See, in previous chapter also we have covered direction cosines and direction ratios. Once again I will revise direction cosines and direction ratios. Okay, chapter number 11 it is. Okay. (3D). So, direction cosines and direction ratios. Okay, direction cosines and direction ratios. Suppose this is your x-axis, this is your y-axis, and this is your z-axis. This is your three-dimensional coordinate system, x, y, and z. Point P in the space. Suppose here is a point. This is point P. Okay, and when you join O to P, it will be position vector of point P. Correct, na? So OP is what? OP is the position vector of point P. This OP vector is what? Position vector of point P. OP vector. Okay, and it is usually denoted by R vector. Okay, it is denoted by R vector. Now, if this R vector makes alpha angle with the x-axis, okay, this R vector makes alpha angle with the x-axis and beta angle with y-axis, beta angle with the y-axis, and gamma angle with the z-axis, then the cosines of alpha, beta, gamma will be called as direction cosines. And what are alpha, beta, gamma? These angles called as direction angles. So, right, if R vector, okay, R vector makes alpha, beta, gamma angles with positive direction of x, y, z axis, okay, axis, and these angles also called as direction angles. Okay, alpha, beta, gamma called as alpha, beta, gamma. They are called direction angles. Direction angles. Direction angles. Then L equals to cos alpha and M equals to cos beta and N equals to cos gamma. So L, M, N or cos alpha, cos beta, cos gamma are known as direction cosines. Okay. Then L, M, N are called as direction cosines. L, M, N are known as direction cosines. Direction cosines. And now, do you remember the relation between direction cosines? What is the relation between direction cosines? Not cos alpha, cos square alpha. Cos square alpha plus cos square beta plus cos square gamma equals to 1. It implies the relation between L and N. Okay, important relation. L square plus M square plus N square equals to 1. Okay, note it. Direction ratios. Next. Direction ratios are the three numbers usually denoted by ABC. Okay. Next, direction ratios. Direction ratios are the three numbers Okay, proportional to direction cosines LMN, direction cosine, that is L upon A, M upon B, and N upon C, and this is equal to some k value. This is equal to some k value. Equals to some k. See, equals to some k. It means if direction ratios are given, we can find the direction cosines. Okay, if direction ratios are given, then we can find direction cosines. If ABC are direction ratios, then the direction cosines can be given by this. L equals to, okay, A upon root over A square plus B square plus C square, okay, plus minus. And what is M? Plus minus B upon root over A square plus B square plus C square. And N equals to plus minus C upon root over A square plus B square plus C square. Okay, if direction ratios are given, you can find the direction cosines. Just you have to divide root over A square plus B square plus C square. Next important things, because direction ratios are the number which are proportional to direction cosines. It means there are infinite direction ratios. Okay, direction ratios are infinite, but direction cosines are unique. There are infinite direction ratios possible. Okay, there are infinite direction ratios possible. Okay, for a line, suppose for a line. Important things: direction cosines of x, y, and z axis. Okay, direction cosines of x, y, and z axis. Direction cosines of x, y, and z axis. You tell me, x axis is also a line. Okay, direct line. Then how much angle x axis makes with the x axis? Any line with itself making 0 degree angle, correct na? And x axis angle with the y axis 90, because coordinate axes are perpendicular, and then x axis makes angle 90 degree with the z axis. It means direction angles 0 degree, 90 degree, 90 degree. So direction cosines cos 0, cos 90, cos 90. Cos 0 is 1, cos 90 is 0. So 0, 1, 1, 0, 0 are the direction cosines of x axis. I'll write here, since what is happening is, since x axis makes 0 degree angle with x axis, okay, it implies alpha is 0 degree, correct? And x axis makes 90 degree angle with y axis, so it implies the direction angle beta is 90 degree. Okay, and x axis makes 90-degree angle with z axis. It implies gamma is 90-degree. So direction cosines, okay? So direction cosines of x axis, tell me students, x axis are cos 0, comma cos 90, comma cos 90. It implies 1, 0 and 0. Now similarly, can you answer me what should be direction cosines of y axis? Y axis 0, 1, 0, because y axis with x axis 90-degree angle, y with y 0-degree, with z 90-degree. So cos 90, cos 0, cos 90, 0, 1, 0. And what is the direction cosines of z axis? 0, 0, 1, correct. Similarly, you can write similarly, okay. Direction cosines of y axis, okay, cos 90, cos 90, cos 0 and cos 90. It implies 0, 1 and 0. And direction cosines of z axis, so cos 90, cos 90, cos 0, it implies 0, 0 and 1. Note it, 0, 0 and 1. So now onwards, remember, whenever I ask direction cosines of x axis, 1, 0, 0. Direction cosines of y axis, 0, 1, 0. Direction cosines of z axis, 0, 0, 1. And why it is? Already you know the reason. Because of direction angles. Note it. Next is direction ratios of a line passing through 2 points. Passing through 2 points. Okay. Suppose you have a line. This is the line. A point and B point. These points in the space, one here, one here. Okay. So usually coordinate we take x1, y1, z1. 2 points. Na? I will say this is coordinate of A is x1, comma y1, comma z1, and I can say this is x2, comma y2, comma z2. Then direction ratios of a line AB passing through A and B. Then what are the direction ratios? So direction ratios of line AB. Okay, simple. X coordinate minus x coordinate given by this R. x2 minus x1, comma y2 minus y1, comma z2 minus z1. Okay, simple. X coordinate of B point minus x coordinate of A point, and y coordinate of B point minus y coordinate of A point. And also you can also write x1 minus x2. This is also correct. Okay, x1 minus x2, y1 minus y2, and z1 minus z2. Because I said na, infinite direction ratio is possible. If you multiply by minus 1, it will become this. But usually we follow this. Find the direction cosines of a line which makes equal angle with the coordinate axis. Okay, which makes equal angle with the coordinate axis. Coordinate axis means with the x axis, with the y axis, with the z axis. Equal angle. It means the direction angles alpha, beta, gamma, they are equal. It implies here in the question number 2, direction angles are equal. Direction angles are equal. it implies alpha equals to beta equals to gamma. Okay, alpha equals to beta equals to gamma. Then L equals to cos alpha. Okay, M equals to cos alpha, and N equals to cos alpha. Or you can write cos beta, cos beta, cos beta, your choice, or cos gamma, cos gamma, cos gamma, because all equal. So either all alpha or all beta or all gamma. Then what is the relation? You know that relation, L square plus n square plus n square equals to 1. L means cos square alpha plus cos square alpha plus cos square alpha equals to 1. So 3 cos square alpha equals to 1. So cos square alpha equals to 1 by 3. Then cos alpha plus or minus 1 by root 3. So direction cosines element, it means plus minus 1 by root 3 comma plus minus 1 by root 3 comma plus minus 1 by root 3. So direction cosines plus minus 1 by root 3 comma plus minus 1 by root 3 comma plus minus 1 by root 3. Okay. Question number 3. Question number 3 is, if a line has the direction ratios minus 18, 12, minus 4, then what are direction cosines? You already know the formula. You have ABC. You have ABC. How to get element? Direction ratio means first A value is minus 18 and B value is 12 and C value is minus 4. Then they are asking direction cosines. ABC given. You want element. So you have to calculate this quantity first. Root over A square plus B square plus C square. What is this? Tell me, students. A square means minus 18 whole square. 18 minus 18 whole square is 18 into 18. How much? How much? 3 to 4. Check. You also check. You. 3 to 4. 12, 144 plus 16. Okay, plus 16. Then simplify. Okay, 484 root 22. Correct, na? $22. It is perfect square root. Okay. Then direction cosines. Direction cosines. L is, the answer was A upon plus minus A upon, na? We can only write the A upon root over A square plus B square plus C square. Okay. And M equals to B upon root over A square plus B square plus C square, comma N equals to C upon root over A square plus B square plus C square. Okay. A is minus 18. So minus 18 upon 22. Okay. And M is 12 by 22. N is minus 4 by 22. And you can simplify again. You can simplify. Minus 9 by 11. And here 6 by 11. And here minus 2 by 11. Okay. These are the direction cosines. Then both are answer correct. I said not direction. This is a line. For a line there are two sets of direction cosines, because a line have two directions. One is this direction, one is this direction. So cos alpha, cos beta, cos gamma, one, and one is cos pi minus alpha, cos pi minus beta, cos pi minus gamma. For a line, two sets of direction cosines. Both are correct. You can use plus minus, but in answer they are using only ABC. Okay, you do correct. Question number 4. You have the 3 points A, B, C. You have 3 points A, B, C. Here. A point, B point, C point. Write ABC values 2, 3, 4, 2, 3, 4, and minus 1, minus 2, and plus 1. 5, 8, 7. Okay, 7. See, with the help of direction ratios, if 3 points are collinear, then direction ratios of AB, only AB, and direction ratios of BC, they should be in the same proportion. So direction ratios, first I will find AB. AB also line segment. So direction ratio of AB is this minus this minus this, and direction ratio of BC, this minus this minus this. So we will have two sets of direction ratios. If they are collinear points, then they will be in the same proportion. Okay. So firstly I will find direction ratios. Direction ratios of line AB, of AB. What are direction ratios? I can say A1 is -1, -2, it is -3. Okay, and B1 it is -2, -3, -5. Okay, and C1 1 -4, -3. Okay, and direction ratios of direction ratios of BC. BC. So let's say A2, B2, C2. A2, B2, C2. A2 value then 5 plus 1. Follow me. 5 plus 1. 6. 8 minus plus 10. 7 minus 1 is 6. Okay. So we have A1, B1, C1, A2, B2, C2. If A1, B1, C1, A2, B2, C2 are in the same proportion, it means A1 upon B1, then I will check A1 upon B1, I will check this A1 upon A2, then B1 upon B2, and then C1 upon C2. Check what is A1 value? -3 upon 6, and this is -5 upon 10. Okay, and -3 upon 6. If you observe, these all equals to -1 upon 2. All are equal, no? It means they are in the same proportion. So, and B point is common. B point is common, so ABC are collinear points. Since point B is common and direction ratios are in proportional, therefore A, B, C are collinear points. A, B, C are collinear points. Okay, A, B, C are collinear points. Last question, let's solve quickly. Question is, find the direction cosines of the sides of the triangle whose vertices are these. You want to find the direction cosines. You can say A, B and C. And then you should write the coordinate of ABC. That what is this? You can say this is A, this is A, this is B and this is C. So A is 3, 5 minus 4, 3, 5 minus 4, and B is -1, 1, 2. Okay, and C is -5 and -5, -2. Okay, you want the direction cosines. You want the direction cosines of the sides of the triangle. So in the triangle, 3 sides. One side is AB side, BC side and AC sides. No problem. Then you have to write first direction ratios of side AB. Firstly, direction ratios of side AB. How to get AB? Let's say this is A1, B1 and C1. Then how to get A1, B1, C1? Coordinate, tell me. A1, B1, C1. So you can write -1, -3. Okay. -1, -3, comma 1 minus 5 and 2 minus plus 4. So what are the direction ratios? -4, -4 and 6. These are the direction ratios of side AB, AB. Okay, then you need direction cosines. Then how to get direction cosines? Tell me. Direction cosines. So, correct. Direction cosines. Direction cosines of side AB. Side AB. So, it will be minus 4 upon root over 4 minus 4 whole square 16 and minus 4 whole square 16 and 6 whole square 36. So, it will be 16, 16 and 36 comma minus 4 upon 4 minus 4 whole square 16, 16, 36 comma 6 by 16 plus 16 plus 36. So, these are the direction cosines. Simplify minus 4 upon 16, 16, 32 plus 36. How much? 68. How? 16, 6, 6. Minus 4 upon root 68 and here 6 upon root 68. Direction cosines of side AB. Similarly, direction cosines of side BC and direction cosines of side AC. Direction ratios first. Okay, direction ratios of side BC. So you can say it is A2 comma B2 comma C2. Okay, A2 B2 C2. A2 B2 C2. So BC means minus 5. BC means minus 5 and minus plus 1. So I am just what I am doing is coordinate of C minus coordinate of B. Okay, so minus 5 upon minus 5 and plus 1 comma minus 5 minus 1 comma minus 2 comma minus 2. So what are direction cosines? Direction ratios coming minus 4 comma minus 6 comma minus 4. Direction ratio of side BC. Then direction cosines of side BC. Direction cosines. Again, here if you see, again you are getting 4 square, 16, 36 and 16. Again root 68 will come. So can I write direct? Same na? And minus 6 by root 68 and here minus 4 by. Similarly for the side AC. Okay, AC I think you can write yourself. Correct na? For AC.